Welcome to the Wandering Mind, a quiet space for curious thinkers. Let your thoughts drift and allow the world to fall away. In the quiet moments before sleep envelops us, there lies an opportunity, a chance to drift gently into the vastness that surrounds our tiny world. Imagine, if you will, a journey through the expanse of the cosmos, a voyage that transcends the boundaries of Earth and takes us to the farthest reaches of the universe. We invite you to relax, to let go of the day's cares, and to join us as we explore the wonders of the universe. The stars await, and with them the stories they have to tell. A tapestry of light and time woven into the fabric of the cosmos. As we drift into sleep, let us carry with us the serenity of the night sky and the promise of the adventures that lie beyond. The night sky, an ever-present canopy of stars and celestial wonders, has long been a source of fascination and contemplation for humanity. As we gaze upwards into the vast expanse, we are not merely observing distant points of light, we are engaging in a timeless dialogue with the universe itself. This dialogue stretches back through the ages, connecting us with those who have come before and those who will follow. Each star, each constellation is a bridge across time, a luminous thread woven into the fabric of our collective human experience. For ancient civilizations, the night sky was a canvas filled with stories, a map to navigate by, and a calendar to mark the passage of time. The constellations were not just groups of stars, but epic tales and mythologies brought to life in the heavens. The Greeks saw mighty heroes and legendary creatures. The Egyptians traced the gods and goddesses who guided their fates. Each culture brought its own perspective to the night sky, painting it with narratives that reflected their understanding of the world. Yet, beyond its mythological significance, the night sky served as an essential tool for early astronomers. It was the original roadmap guiding travelers across uncharted seas. The North Star, steadfast and unerring, provided a fixed point from which to navigate the unknown. Mariners relied on the predictable dance of stars to chart their courses, trusting the cosmos to lead them to new lands. These celestial patterns, once memorized, became a guidebook written in the language of the stars. Our relationship with the night sky has always been one of both dependency and wonder. It is a reminder of our smallness in the face of the universe's grandeur and a testament to our enduring curiosity. The stars invite us to look beyond our immediate surroundings and ponder the infinite. They compel us to question, to seek out the unknown, and to push the boundaries of our understanding. As the centuries unfolded, the night sky continued to captivate humanity's imagination, leading to profound scientific discoveries. The telescope, a revolutionary invention, allowed us to peer deeper into the cosmos, revealing secrets that had been hidden from the naked eye. With each new advancement, our picture of the universe grew clearer, yet more complex. We discovered that the stars were not solitary beacons, but part of vast galaxies, swirling and spiraling in the cosmic ballet of creation. Among the pioneers who expanded our comprehension of the stars was Galileo Galilei, who, with his modest telescope, glimpsed the moons of Jupiter and the phases of Venus. His observations challenged the prevailing view of an Earth-centered universe, setting the stage for future astronomers to further unravel the mysteries of the cosmos. The night sky, once thought immutable, was revealed to be dynamic, a realm of constant change and motion. In more recent times, astronomers like Edwin Hubble have continued to push the limits of our cosmic understanding. Hubble's work on the expansion of the universe transformed our perception of the night sky, suggesting that the universe itself is not static but ever-growing.
With each discovery, the night sky becomes not just a window to the universe, but a mirror reflecting our own evolving knowledge and insight. Yet, even as we unravel the scientific intricacies of the cosmos, the night sky retains its capacity to inspire awe and wonder. It is a reminder of the beauty that lies beyond our immediate grasp, a testament to the universe's boundless creativity. The stars beckon us to dream, to imagine what might be possible, and to find our place within this vast celestial tapestry. As we lie beneath the canopy of stars, we are connected to a lineage of stargazers who have found solace and inspiration in the night sky. It is a shared experience, transcending time and culture, uniting us in our quest for understanding. The night sky invites us to pause, to reflect, and to consider the infinite possibilities that lie beyond our world. In this serene contemplation, we come to appreciate the delicate balance of our existence. The night sky, with its twinkling constellations and distant galaxies, is both a humbling reminder of our insignificance and a celebration of our potential. It is a call to explore, to discover, and to never cease in our pursuit of knowledge. And so, as we turn our gaze upwards, we are reminded that the night sky is not just a window to the universe, but a window to ourselves. It is a testament to the enduring human spirit, ever curious, ever seeking, and ever inspired by the mysteries of the cosmos. In the quiet moments beneath the stars, we find not only answers, but also the courage to ask new questions, to dream new dreams, and to continue our journey into the unknown.
In the vast, velvety expanse of the cosmos, stars serve as luminous beacons, drawing our gaze upwards and filling the night sky with their gentle glow. These celestial bodies, with their twinkling allure, have inspired countless myths, guided explorers across oceans, and sparked the curiosity of those who seek to unravel the mysteries of the universe. Yet, beyond their beauty lies a complex and fascinating story, the life cycle of stars, a cosmic dance that spans millions to billions of years. Stars are born in the cradle of cosmic nurseries, known as nebulae. These are immense clouds of gas and dust scattered throughout galaxies like the Milky Way. Within these nebulae, regions of denser material begin to collapse under the relentless pull of gravity. As the material collapses, it begins to heat up, forming a protostar at the heart of a swirling disk of gas and dust. This is the embryonic stage of a star, a delicate balance between the inward force of gravity and the outward pressure from heat. As the protostar continues to accrete material, it grows hotter and denser. Eventually, when the core temperature reaches about 10 million degrees Celsius, nuclear fusion ignites. It is this fusion, the process of hydrogen atoms fusing into helium, that marks the birth of a true star. The energy released from fusion provides the outward pressure needed to counteract gravity, thus stabilizing the young star. This is the beginning of what astronomers call the main sequence phase, a period of relative calm and stability that can last for billions of years. During the main sequence, stars shine steadily, their light a beacon across the cosmic ocean. Our own Sun is a main sequence star, and it's in this unassuming phase where stars spend the majority of their lives. The energy generated in the core travels outward, eventually reaching the surface and radiating into space as light and heat. It's remarkable to consider that the sunlight warming our planet is the result of countless nuclear reactions occurring deep within the Sun's fiery heart.
As the stars continue to fuse hydrogen into helium, changes begin to occur. For stars like our Sun, once the hydrogen in the core is exhausted, the core contracts and heats up, while the outer layers expand and cool. This transition leads to the star becoming a red giant. Red giants are expansive, often engulfing nearby planets and altering the celestial neighborhood. Yet, even in this seemingly destructive phase, there is a serene beauty. The outer layers of the star, now cooler and more diffuse, cast a warm glow reminiscent of a sunset. The fate of a star depends largely on its initial mass. For stars similar in size to our Sun, the red giant phase eventually leads to the shedding of outer layers, creating a planetary nebula. What remains is the core, now a white dwarf, a dense and hot remnant slowly cooling over billions of years. These white dwarfs, though faint, continue to shine quietly, a testament to their once vibrant past. For stars much more massive than the Sun, the end is more dramatic. As these giants exhaust their nuclear fuel, they undergo a series of increasingly rapid nuclear reactions, fusing heavier and heavier elements in their core. When iron, the last element that can be fused without consuming energy, accumulates in the core, fusion halts. The core collapses under gravity, leading to a cataclysmic explosion known as a supernova. This explosion is one of the universe's most energetic events, briefly outshining entire galaxies and scattering elements across space. The remnants of a supernova can form either a neutron star or, if the original star was massive enough, a black hole. They represent the stellar endgame, a mysterious and intriguing conclusion to the life of a massive star. Despite their varied fates, stars leave a lasting legacy. The elements forged in their core and dispersed through supernova enrich the interstellar medium, seeding future generations of stars and planets. In this way, stars are both creators and destroyers, playing a pivotal role in the ongoing cycle of cosmic evolution. As we look up at the night sky, it's humbling to know that many of the stars we see are in various stages of this life cycle. Some may be in the tranquil main sequence, like our Sun, while others might be nearing the end of their luminous journey. Each point of light is a testament to the magnificent processes occurring across the universe, processes that have shaped the cosmos and continue to influence it in profound ways. In the silence of the night, as we contemplate the stars, we are reminded of the vastness and complexity of the universe. Stars are not merely distant lights, but dynamic entities with lives of their own, each telling a story that spans eons. They are the cosmic beacons that illuminate the night, guiding not just our physical journeys, but our intellectual and philosophical ones as well. In their light, we find both the questions and the inspiration to seek the answers that lie in the realms beyond our reach.
In the quiet, velvety expanse of the night sky, galaxies reveal themselves as majestic islands adrift in the boundless cosmic ocean. These sprawling collections of stars, gas, and dust captivate our imagination and beckon us to explore their mysteries. As we meander through the universe, we find galaxies in an astonishing variety of shapes and sizes, each with tales to tell and secrets to uncover. Galaxies, these grand celestial structures, can be thought of as the great cities of the cosmos. Just as cities on Earth teem with life, galaxies teem with stars.
Each of these stars might cradle its own planets, potential havens for life and mysteries awaiting discovery. On a clear night, when we gaze up at the Milky Way, we are peering into the heart of our own galactic city, a spiraling congregation of hundreds of billions of stars. Our Milky Way, a familiar spiral galaxy, serves as a comforting point of reference. It is a stellar metropolis, its arms swirling outwards like a gentle cosmic whirlpool. The stars within these spirals orbit the galactic center, a bustling hub dominated by a supermassive black hole, a gravitational anchor around which everything revolves. This is a common feature in many spiral galaxies, an enigmatic force at their core, quietly influencing the dance of stars and planets. Yet not all galaxies are spiral in form. Some galaxies, like the grand and elliptical giants, appear more like celestial rugby balls, smooth and featureless to the casual observer. These elliptical galaxies contain older stars and lack the spiraling arms of their cousins, suggesting a quieter, perhaps more ancient existence. With their stars orbiting in random directions, they present a cosmic ballet that is less structured, yet equally captivating. Then there are the irregular galaxies, rebellious in their lack of distinct shape. They are the cosmic vagabonds, often distorted by gravitational interactions with their galactic neighbors. These galaxies tell stories of cosmic collisions and galactic mergers, of forces that mold and reshape them over eons. Their chaotic forms remind us that the universe is a dynamic, ever-evolving tapestry. The study of galaxies is not merely an exercise in cataloging their shapes and sizes. It is an exploration of time itself. Light from distant galaxies travels for millions, even billions of years before reaching our eyes. Each galaxy is a glimpse into the past, a snapshot of a moment long gone. When we observe a galaxy billions of light years away, we are seeing it as it was when the universe was young, a time traveler's view into the cosmic dawn. The sheer diversity of galaxies prompts us to wonder about their origins. How did these vast collections of stars come into being? The prevailing theory suggests that galaxies formed from primordial fluctuations in the density of matter in the early universe. Over time, these fluctuations grew under the influence of gravity, drawing in gas and dust to form the first stars and galaxies. These early structures then evolved, interacting with one another, merging and growing in size and complexity. Galaxies are not isolated entities. They often exist in clusters and superclusters bound together by gravity. Our Milky Way belongs to the local group, a modest cluster of galaxies that includes the Andromeda Galaxy, our closest spiral neighbor. Andromeda, like two ships on a collision course, is slowly heading towards the Milky Way, a cosmic rendezvous set for billions of years in the future. Such interactions are common in the universe and play a crucial role in the evolution of galaxies, reshaping them and triggering bursts of star formation. The beauty and complexity of galaxies have inspired generations of astronomers and dreamers alike. In the 20th century, Edwin Hubble, an American astronomer, revolutionized our understanding of galaxies. He demonstrated that the universe was far larger than previously imagined, and that galaxies were not nebulae within the Milky Way, but rather separate island universes in their own right. Hubble's work laid the foundation for modern cosmology, expanding our perception of the universe and our place within it. Yet, more recently, the work of astronomers like Vera Rubin has shed light on the elusive nature of dark matter, a mysterious form of matter that does not emit light or energy, but exerts a gravitational influence on galaxies. Rubin's observations of the rotational speeds of galaxies provided compelling evidence for the existence of dark matter, hinting at the unseen forces that shape the cosmos. As we continue to explore the universe, galaxies remain at the forefront of our quest for knowledge. They are the laboratories where the laws of physics play out on a grand scale, where the life cycles of stars unfold, and where the potential for life beyond Earth might one day be realized. Each galaxy, with its unique composition and history, adds a new chapter to the cosmic story, inviting us to ponder the infinite possibilities of the universe. In contemplating galaxies, we find ourselves both humbled and inspired. Humbled by the vastness of the universe and the smallness of our place within it. Inspired by the beauty and complexity that emerges from the simple interplay of matter and energy. As we drift into sleep, these cosmic islands remind us of the boundless wonders that await our discovery, both in the universe around us and within the depths of our wondering minds.
In the stillness of the night, as we find ourselves drifting on the edge of sleep, it's comforting to imagine the vast, gentle sweep of our home galaxy, the Milky Way. Stretching out like a celestial river of stars across the velvet sky, it has guided travelers, inspired poets, and sparked the imagination of astronomers throughout the ages. Our galaxy is a spiral, a grand design of cosmic architecture, where stars and planets dance in a harmonious swirl. It is a place of both familiarity and mystery, much like our own earthly abode, yet vastly more expansive. The Milky Way is a barred spiral galaxy, a common structure in the universe, yet each one is distinct. Imagine its shape as a magnificent disk with a bulge at the center, where stars are densely packed, creating a glowing hub of light and energy. This central bulge is where we find an intriguing object, Sagittarius A star, a supermassive black hole with the mass of around 4 million suns. Its presence is a testament to the forces of gravity and time, bending the very fabric of space around it. Spiraling out from this luminous center are the galaxy's majestic arms. These arms are not solid objects, but rather regions where stars are more densely populated, creating a visual spiral pattern. The arms are sites of new star formation, where clouds of gas and dust coalesce under gravity to ignite the birth of new suns. Our own solar system resides in one of these arms, the Orion Arm, a relatively quiet neighborhood within this bustling galactic metropolis. The Milky Way is estimated to contain between 100 and 400 billion stars, a number so vast that it stretches the limits of our comprehension. If we were to count each star at a rate of 1 per second, it would take us more than 3,000 years to count them all. Yet, despite this multitude, the space between stars is immense, a vast void punctuated by the occasional nebula or cluster. Within these arms lie other wonders, the glittering clusters of stars known as globular clusters, some of which are nearly as old as the universe itself. These ancient congregations of stars orbit the galaxy's center like bees around a hive, each one a testament to the galaxy's enduring nature. Our understanding of the Milky Way has expanded over time, guided by the observations of astronomers who have peered into the skies with ever-improving telescopes. One such astronomer was William Herschel, who, in the late 18th century, attempted to map the shape of the galaxy, laying the groundwork for our modern understanding.
His work was like a first sketch, a hint of the grand design that was to be revealed by later scientists with more powerful instruments. In the 20th century, Edwin Hubble's discovery that the universe is expanding changed our perception of the Milky Way, revealing that it is but one galaxy among billions. Yet, within its familiar contours, the Milky Way remains a focal point for our exploration of the cosmos. Instruments like the Hubble Space Telescope have allowed us to gaze deeper into its structure, unveiling the beauty and complexity of its form. The Milky Way is not a static entity. It is alive with motion. Stars orbit the galactic center in paths shaped by gravity, taking hundreds of millions of years to complete a single orbit. As we lie on our backs on a summer's night, gazing up at the starry band of the Milky Way, we are witnessing a snapshot of a cosmic ballet that unfolds over eons. Yet, for all its splendor, much of the Milky Way remains shrouded in mystery. Dark matter, an unseen substance that does not emit light or energy, is thought to make up a significant portion of our galaxy's mass. Its presence is inferred by the gravitational effects on visible matter, yet its true nature remains one of the great puzzles of modern astronomy. As we drift towards sleep, we can ponder the role our galaxy plays in the grand tapestry of the universe. The Milky Way is our cosmic home, a place where the elements forged in the hearts of stars have given rise to life, to planets, and to the possibility of countless other worlds. It is a reminder of our connection to the universe, a thread in the vast fabric of existence. In the quiet moments of reflection, we can appreciate the Milky Way not only as a collection of stars and planets, but as a symbol of the wonder and curiosity that drive us to explore the unknown. It is a beacon in the night sky, a guide for the wandering mind, inviting us to dream, to discover, and to find our place among the stars. As you close your eyes, let the gentle swirling arms of our galaxy cradle you, a reminder that even in the vastness of the cosmos, we are never truly alone.
In the vast theater of the cosmos, black holes stand as some of the most enigmatic characters, shrouded in mystery and cloaked in the deepest of shadows. These celestial phenomena captivate the imagination, drawing us into their gravitational embrace with a blend of awe and apprehension. They are the universe's silent sentinels, hidden in the fabric of space and time, challenging our understanding of physics and our place within the cosmic tapestry. The story of black holes begins with the life of a star. Imagine a star, much like our own sun, but with a mass several times greater. Throughout its life, it shines brightly, fueled by nuclear fusion at its core. This process creates a delicate balance between the outward pressure of radiation and the inward pull of gravity. As the star exhausts its nuclear fuel, this balance is disrupted and gravity begins to dominate. In its final act, the star undergoes a dramatic transformation. The core collapses under its own weight, compressing into an incredibly dense point known as a singularity. Surrounding this singularity is the event horizon, a boundary beyond which nothing, not even light, can escape. This is the birth of a black hole, a region where gravity is so intense that it warps the very fabric of space-time. Black holes are often described as cosmic vacuum cleaners, but this metaphor doesn't quite capture their true nature. They do not actively seek out material to consume, yet their immense gravitational pull can draw in nearby matter, forming a swirling disk of gas and dust known as an accretion disk.
As matter spirals inward, it heats up and emits X-rays, providing astronomers with a window into the otherwise invisible realm of the black hole. The concept of black holes, while now a cornerstone of modern astrophysics, was once viewed with skepticism. The term black hole itself was coined only in the 1960s by physicist John Archibald Wheeler, although the idea traces back to the 18th century. It was the work of Einstein, with his theory of general relativity, that provided the framework for understanding these cosmic enigmas. His equations predicted the existence of black holes, yet even Einstein himself found the notion unsettling. As we ponder the existence of black holes, we must also consider their role within the cosmic dance. They are not merely solitary reapers, but active participants in the evolution of galaxies. Supermassive black holes, millions or even billions of the mass of our own Sun, reside at the centers of most galaxies, including our own Milky Way. Their gravitational influence helps regulate the growth and formation of stars, shaping the structure of galaxies over billions of years. One of the most intriguing aspects of black holes is the information paradox, a puzzle that continues to confound physicists. According to quantum mechanics, information about matter entering a black hole should be preserved. Yet general relativity suggests it is lost forever. This paradox challenges our understanding of the fundamental laws of physics and has led to heated debates and novel theories, including Stephen Hawking's proposal of Hawking radiation, a theoretical process by which black holes could emit radiation and ultimately evaporate. In recent years, black holes have transitioned from theoretical curiosities to observable phenomena, thanks in large part to advancements in technology. The Event Horizon Telescope, a global network of radio observatories, captured the first image of a black hole's shadow in 2019, providing a glimpse into the heart of these cosmic giants. This landmark achievement confirmed many predictions of general relativity and opened new avenues for exploration. Yet, despite these strides, black holes remain enigmatic. They are the ultimate paradoxes, embodying the extremes of the universe, where time stands still and gravity reigns supreme. To contemplate a black hole is to peer into the depths of the universe's mysteries, to engage with questions that stretch the limits of our understanding and imagination. As we drift into the realm of sleep, let us carry with us the image of these cosmic giants, silently shaping the universe from their hidden vantage points. In their presence, we are reminded of the boundless curiosity that drives us to seek knowledge and the profound mysteries that continue to elude our grasp. The journey into the unknown is a dance of discovery, and black holes, with their enigmatic allure, are the partners that lead us deeper into the cosmic waltz.
As we drift through the cosmos, our gaze inevitably turns to the distant stars, those ancient beacons that have guided humanity for millennia. Yet, in recent times, our curiosity has ventured beyond the stars themselves to the planets that might orbit them. These are the exoplanets, worlds beyond our Sun, each one a potential harbor of life, or at least a hint of what might be possible under the right conditions. It's a thought that stirs the imagination, opening vistas of possibility that are both humbling and exhilarating. It was not so long ago that the idea of planets outside our solar system was purely speculative. The very first confirmed detection of an exoplanet occurred in 1992, around a pulsar, an unlikely host for planets given the violent nature of these rapidly spinning neutron stars. And yet, there they were, planets in orbit, defying expectations. This discovery was a gentle reminder from the universe that it often harbors surprises, waiting just beyond the limits of our understanding. As the years rolled on, technology advanced, and with it our ability to peer deeper into the cosmos. The Kepler Space Telescope, launched in 2009, became a pivotal tool in this exploration. Its mission was to observe the subtle dimming of stars as planets passed in front of them, a method known as the transit method. Kepler's findings were nothing short of revolutionary, identifying thousands of potential exoplanets and confirming that our galaxy is teeming with them. The revelation that planets are common rather than rare was a fundamental shift in our understanding of the universe. In the search for exoplanets, astronomers have uncovered a dazzling array of worlds, each with its own unique characteristics. There are gas giants similar to Jupiter, rocky planets like Earth, and even exotic types like hot Jupiters, gas giants that orbit perilously close to their stars, leading to extreme temperatures. Some planets exist in systems with multiple stars, casting complex shadows and creating a dance of light and gravity that challenges our perception of what a solar system can be. Yet, among these myriad worlds, there are some that capture our attention more than others, those that reside in the so-called habitable zone of their stars. This is the region where conditions might be just right for liquid water to exist on a planet's surface, a crucial ingredient for life as we know it. The discovery of planets in these zones, particularly those that are Earth-sized, ignites the imagination with thoughts of alien life or the conditions that might support it. Consider the planet Kepler-186f, the first Earth-sized planet found in a star's habitable zone. Located about 500 light-years away, it orbits a red dwarf star, cooler and dimmer than our Sun. While we know little about the atmosphere or surface conditions of Kepler-186f, its existence alone suggests that there may be many such worlds scattered throughout the galaxy, each with its own story to tell. The notion of life beyond Earth, even in microbial form, is tantalizing. It challenges us to redefine our understanding of life itself. As we study these distant worlds, we must also ponder the conditions that might foster life in forms unfamiliar to us. Could life thrive in environments vastly different from our own, perhaps beneath the icy crust of a distant moon, or in the thick, crushing atmosphere of a far-off gas giant? In these contemplations, we find echoes of our own origins. The search for exoplanets and the potential for life beyond Earth is not just an exploration of other worlds, but a journey that reflects back upon our own planet. It urges us to consider Earth not as a solitary outpost in a barren cosmos, but a part of a vast interconnected tapestry of celestial bodies, each a chapter in the broader narrative of the universe. Moreover, the study of exoplanets inspires us to think about the future, about the possibility of interstellar travel and the distant worlds we might one day visit. It stirs dreams of exploration and discovery, of humanity reaching beyond its cradle to touch the stars themselves. These dreams, while distant, are not beyond the realm of possibility. They are the aspirations that drive scientific endeavor and human curiosity. As we continue to search the skies for new worlds, we are reminded of the words of Carl Sagan, who eloquently captured the humbling nature of our cosmic journey. Each exoplanet discovered is a reminder of the vastness of space and the preciousness of life, wherever it may be found. It is a call to cherish our own planet, even as we look to the stars, for Earth is the only home we know, a fragile oasis in the immense and unfathomable ocean of the universe. And so we drift along, on this gentle tide of discovery, our minds wandering among the stars, comforted by the thought that in the grand scale of the cosmos, we are but one part of a magnificent whole, a universe rich with possibility, where each new discovery carries us further along the path of understanding and wonder. As we close our eyes and let the thoughts of distant worlds lull us into slumber, we find solace in the beauty of the unknown and the endless quest to uncover it.
In the vast, enveloping silence of the cosmos, where stars twinkle like distant dreams and galaxies spin their luminous tails, there lies a question as old as curiosity itself. Are we alone in the universe? This question, whispered in the quiet moments of stargazing and pondered in the halls of science, has captivated human minds for centuries. It beckons us to explore beyond our earthly confines, to peer into the dark velvet of space with hope and wonder. The search for extraterrestrial life is an intricate tapestry of science, imagination, and profound philosophical inquiry. At its heart, this quest is driven by a simple yet profound desire to understand our place in the cosmos. To find life beyond Earth would not only answer this age-old question, but also redefine our understanding of life itself. Our journey begins with the conditions that make life as we know it possible. Here on Earth, life thrives in a delicate balance of elements and conditions. Water, in its liquid form, is crucial, a solvent in which the chemistry of life can unfold. The presence of water in liquid form, however, requires a planet to be in the so-called habitable zone of its star, a region where temperatures are just right for liquid water to exist. This concept, often referred to as the Goldilocks zone, is a cornerstone in the search for habitable planets. Beyond water, life needs a stable environment with a source of energy. On Earth, the sun provides this energy, driving photosynthesis and warming the planet. This energy sustains the complex web of life that has evolved over billions of years. Yet, scientists have come to understand that life might not be confined to the sunlit surfaces of planets. Earth's own deep oceans, where sunlight never reaches, are home to thriving ecosystems around hydrothermal vents. Here, life draws energy not from sunlight, but from the heat and chemicals expelled from the Earth's interior. This discovery has expanded our view of where life might exist, suggesting that even the icy moons of the outer solar system, like Jupiter's Europa or Saturn's Enceladus, could harbor life beneath their frozen surfaces. The search for extraterrestrial life extends beyond our solar system to the myriad exoplanets orbiting distant stars. With advances in technology, we have identified thousands of these distant worlds, some residing within their star's habitable zone. Instruments like the Kepler Space Telescope have transformed our understanding of the galaxy, revealing that planets orbiting stars are more the rule than the exception. This cosmic census has invigorated the scientific community, as each new discovery holds the potential to host life. Yet, the presence of a habitable environment does not guarantee life.
To detect life beyond Earth, scientists employ a range of techniques, searching for what are known as biosignatures, indicators of life that can be detected from afar. These might include certain gases in a planet's atmosphere, like oxygen or methane, which on Earth are largely produced by living organisms. The search for biosignatures is a delicate dance of observation and interpretation, as these gases can also be produced by non-biological processes. As we peer into the universe, the question of intelligent life inevitably arises. Are there other beings somewhere out there, gazing up at their night sky and wondering if they are alone? The search for intelligent extraterrestrial life is a more daunting challenge. Projects like SETI, the search for extraterrestrial intelligence, have been listening for signals from other civilizations, hoping to catch a whisper across the void. Despite decades of listening, the silence remains unbroken. But this silence does not dishearten. It fuels our curiosity, urging us to refine our methods and continue the search. The search for life beyond Earth is not just a scientific endeavor, it is a profound philosophical journey. It challenges us to consider what it means to be alive and how life might adapt and evolve in environments vastly different from our own. It invites us to contemplate the nature of intelligence and the possibilities of communication with beings who might perceive the universe in ways we cannot yet imagine. In the stillness of the night, as we gaze upon the stars, we are reminded of our shared origins. Every atom in our bodies was forged in the heart of a star long ago, scattered across the cosmos, and eventually gathered here on this small blue planet. This cosmic connection unites us with the universe and with any life that may exist beyond our tiny world. As we continue our search, we do so with humility and a sense of wonder, aware that the answers we seek may not come in our lifetime or even in the next. Yet the journey itself, with its questions and discoveries, enriches our understanding of the universe and our place within it. Whether we find life elsewhere or not, the quest itself is a testament to the boundless curiosity and enduring spirit of exploration that define us as a species. And so we listen to the stars, we watch the skies, and we dream of what might be, ever hopeful that one day, in the vastness of space, we might find a kindred spirit gazing back at us.
In the quiet vastness of our universe, where silence whispers more than any sound could, lie the enigmatic nebulae. These celestial clouds are the vibrant, delicate tapestries of the cosmos, spun from gas and dust. Their beauty is not merely skin-deep, it is intricately woven into the very fabric of the universe's life cycle. Nebulae, you see, are more than just ethereal wonders to be admired from afar. They are the cosmic nurseries where the stars themselves find their genesis. Imagine, if you will, floating gently through the cosmos, carried by the invisible currents of space-time. As we drift, our gaze is drawn to the swirling, kaleidoscopic structures of a nebula. These formations, often many light-years across, are painted in hues of pink, blue, green, and gold, each color hinting at the elements contained within. Hydrogen, the most abundant element in the universe, often emits a characteristic red or pink glow when excited by radiation. Helium, oxygen, and other elements add their own subtle tints to the cosmic palette. The birth of a star within these nebula begins in a deceptively simple manner. Over vast stretches of time, the gentle pull of gravity acts upon the particles within a nebula, causing them to clump together.
This process is far from hurried. It takes millions of years for these clumps to grow dense enough to form what we call a protostar. During this time, collisions between particles generate heat, and the protostar begins to shine faintly, cocooned in its dusty shell. It is a fragile light, the first flicker of what will eventually become a new sun. One might wonder how we, mere earthly beings, have come to understand such distant phenomena. It is partly thanks to the pioneering work of astronomers like Vera Rubin, who, through her observations, helped us appreciate the dynamic and often hidden forces at play in the universe. Her work, along with that of others, have illuminated the dark corners of space, revealing the processes that turn cosmic dust into the brilliant stars that dot our night sky. As the protostar continues to accrete material from its surrounding nebula, a delicate balance is reached. The inward pull of gravity is counteracted by the outward pressure from nuclear fusion, which ignites at the core of the forming star. The fusion of hydrogen into helium releases vast amounts of energy, and the star emerges from its cocoon, a new beacon in the cosmic sea. Thus, from the quietude of a nebula, a star is born, ready to begin its long, luminous journey across the universe. The nebula itself is not static. It is in constant flux, shaped by the forces of gravity, radiation, and stellar winds. Some of the most iconic images of our universe, such as the pillars of creation in the Eagle Nebula, capture these dynamic processes in exquisite detail. These pillars, towering structures of gas and dust, are slowly eroded by the intense radiation from nearby young stars. It is a reminder of the delicate balance between creation and destruction that governs the cosmos. The beauty of nebula is not limited to their role as stellar nurseries. Some, like the Crab Nebula, are remnants of supernovae, the explosive deaths of massive stars. These nebulae tell a different story, one of renewal and transformation, as the material ejected in the explosion enriches the surrounding space with the heavier elements forged in the star's core. In this way, nebulae play a crucial role in the cosmic cycle of matter, seeding the universe with the building blocks of planets and ultimately life itself. As we reflect upon the nebulae, it is worth considering our own connection to these distant clouds. Every atom in our bodies was forged in the heart of a star, a testament to the profound unity of all things in the universe. We are, quite literally, made of stardust, connected to the cosmos in ways that are both humbling and awe-inspiring. In the stillness of night, as we gaze upwards at the star-studded sky, let us take a moment to ponder the birthplaces of these celestial wonders. The nebulae, with their serene beauty, invite us to dream of the stars they nurture and the endless possibilities they represent. They remind us that even in the apparent chaos of the universe, there is an underlying order, a dance of creation and transformation that has been unfolding for billions of years. So, as we gently drift through the corridors of sleep, let our minds wander among the nebula. Let us be carried on the cosmic winds to those distant places where stars are born, and watch as the universe weaves its eternal tapestry of light and wonder. In doing so, we find not only a deeper understanding of the cosmos, but also a quiet peace that lulls us into dreams of distant worlds and the mysteries that lie beyond.
In the quiet, vast expanse of the universe, there are celestial wonders that stand as beacons of light. They are pulsars and quasars, often referred to as the universe's lighthouses. These extraordinary phenomena guide astronomers to deeper understandings of the cosmos, illuminating the mysteries that lie in the dark stretches of space. Imagine, if you will, a lighthouse on Earth's rocky shores, its beam cutting through the fog, guiding sailors safely home. Similarly, pulsars and quasars send out their signals across the vast gulfs of space, offering us glimpses into the workings of the universe. Pulsars are the remnants of massive stars that have gone supernova, their core collapsing into an incredibly dense neutron star. Picture a star that has exhausted its nuclear fuel, its outer layers explosively cast off in a dazzling supernova display. What remains is a neutron star no bigger than a city, yet possessing a mass greater than our Sun. It's as if all the mass of a mountain were compressed into a single sugar cube. These neutron stars rotate at incredible speeds, some spinning hundreds of times per second. As they rotate, they emit beams of electromagnetic radiation from their magnetic poles. If these beams are oriented such that they sweep across Earth, we observe them as pulses of light and radio waves, much like the rotating beam of a lighthouse. It is this regular pulsing that gives pulsars their name, a portmanteau of pulsating star. The discovery of the first pulsar in 1967 was an unintentional triumph of curiosity and persistence. Jocelyn Bell Burnell, a postgraduate student at the time, was sifting through data from a radio telescope when she noticed an unusual repeating signal. At first, it was whimsically dubbed LGM1, short for Little Green Men, due to its regularity and precision, a reminder of how much we didn't know about the universe then, and perhaps still don't. Pulsars serve as cosmic clocks, their regularity allowing astronomers to measure time with extraordinary precision. The pulsar known as PSR 1919 plus 21, the very first discovered, rotates once every 1.337 seconds. Such precision allows for a range of scientific investigations, from testing the limits of Einstein's general relativity to navigating spacecraft across the solar system. Now, let us drift further into the cosmos to meet the quasars. Quasars, or quasi-stellar objects, are the bright hearts of distant galaxies, their light often outshining entire galaxies. They are believed to be powered by supermassive black holes at the centers of these galaxies, accreting matter and converting it into energy with astonishing efficiency. Imagine a whirlpool in a river, drawing everything around into its depths. Similarly, a quasar's black hole pulls in gas and dust, forming an accretion disk. As the material spirals inward, it heats to extreme temperatures and releases an immense amount of energy, sometimes casting light that travels billions of light-years to reach us. The discovery of quasars in the 1960s opened a new chapter in our understanding of the universe. Martin Schmidt, a Dutch astronomer, identified the first quasar by its unusual spectral lines, eventually realizing they were redshifted to an extent that indicated it was unimaginably far away. This realization was a profound moment, revealing the true scale of the universe and the power of these distant objects. Quasars, like pulsars, serve as beacons, but their light tell us about the early universe. Because they are so distant, observing them allows us to look back in time, to an epoch when the universe was young. They illuminate the large-scale structure of the cosmos,
tracing the web of galaxies and clusters that form the scaffolding of our universe. In their light, we find clues about the formation and evolution of galaxies, the distribution of matter, and the expansion of the universe itself. They are, in essence, the scribes of the cosmos, writing the history of the universe in light. In the gentle rhythm of the universe, pulsars and quasars pulse and shine, guiding us through the cosmic ocean. They stand as reminders of the incredible forces at play in the universe, from the death of stars to the birth of galaxies, each a testament to the power and beauty of nature. As we lie beneath the stars, letting their light guide our thoughts, we can take comfort in the knowledge that the universe is vast and filled with wonders beyond our wildest dreams. Pulsars and quasars, in their silent vigil, remind us that we are part of something tremendously grand, a tapestry woven with the light of 1 billion stars.
In the vast expanse of the universe, where silence reigns and stars twinkle like distant memories, there lies an intricate tapestry woven from the very fabric of existence. This is the cosmic web, a grand structure that stretches across the cosmos, connecting galaxies like beads on an invisible string. It is a testament to the universe's penchant for order amid chaos, a delicate balance that has shaped everything from the smallest atom to the largest galaxy cluster. Imagine, if you will, a spider's web glistening in the morning dew, each thread a conduit of strength and fragility. The cosmic web mirrors this delicacy on an unfathomable scale. Composed primarily of dark matter, the enigmatic and invisible substance that neither emits nor absorbs light, this web forms the backbone of the universe. It dictates the distribution of galaxies, guiding them along its filaments like a gentle shepherd leading a cosmic flock. Our journey through the cosmos begins with a single thread, a filament of dark matter stretching across millions of light years. These filaments converge at nodes, creating vast galaxy clusters that serve as the universe's bustling metropolises. Here, billions of stars, planets, and other celestial bodies dance in a gravitational waltz, their movements dictated by the unseen hand of dark matter. To understand the cosmic web, we must first delve into the nature of dark matter itself. Though it remains elusive, scientists have determined that dark matter constitutes about 27% of the universe, dwarfing the mere 5% comprised by ordinary matter, the stars, planets, and life as we know it. The remaining 68% is dark energy, a mysterious force driving the accelerated expansion of the universe. Dark matter's presence is inferred through its gravitational effects. Like a ghostly puppeteer, it shapes the universe by pulling on ordinary matter, creating the vast cosmic structures we observe today. Without dark matter, galaxies as we know them would not exist, for it is the gravitational glue holding them together. The cosmic web's formation is a story billions of years in the making, beginning shortly after the Big Bang. In those early moments, the universe was a hot, dense soup of particles with tiny fluctuations in density. These fluctuations, mere whispers in the cosmic cacophony, served as seeds for the structures that would eventually form. As the universe expanded and cooled, dark matter began to clump together, drawn by gravity into a vast network of filaments. Over time, these filaments became the scaffolding upon which galaxies formed. The densest regions, where multiple filaments intersect, became the birthplaces of galaxy clusters.
Our own Milky Way resides in such a region, nestled within a vast filament known as the Laniakea supercluster, a sprawling structure containing over 100,000 galaxies. The cosmic web is not static. It is a dynamic entity, constantly evolving as galaxies migrate along its strands. This movement is akin to a great cosmic ballet, with celestial bodies spinning and twirling across the stage of the universe. Observing this dance provides insights into the underlying physics governing the cosmos, revealing the intricate interplay between dark matter and ordinary matter. In recent years, astronomers have employed sophisticated simulations to study the cosmic web. These simulations, such as the Millennium Run and Illustris project, use powerful supercomputers to model the universe's evolution from the Big Bang to the present day. By comparing these virtual universes to observations of the actual cosmos, scientists refine their understanding of the forces shaping the cosmic web. One such observation comes from the Sloan Digital Sky Survey, a monumental effort to map the universe in unprecedented detail. This survey has unveiled the large-scale structure of the cosmos, revealing the vast filaments and voids that define the cosmic web. These voids, vast regions nearly devoid of galaxies, serve as stark contrasts to the densely populated nodes, highlighting the universe's intricate architecture. The cosmic web is not merely a backdrop against which the universe's drama unfolds, it is an active participant in the cosmic story. It influences the formation and evolution of galaxies, dictating their shapes, sizes, and interactions. The web's gravitational pull can trigger collisions between galaxies, sparking bursts of star formation and reshaping their structures. In contemplating the cosmic web, one cannot help but marvel at the sheer scale and complexity of the universe. It is a reminder of our own insignificance, a humbling testament to the vastness of the cosmos. And yet, within this grand structure, we find a sense of connection, a reminder that we too are part of this cosmic tapestry. As we drift off into the embrace of sleep, let us carry with us the image of the cosmic web, a delicate, intricate network that binds the universe together. It is a symbol of the universe's unity and diversity, a reflection of the hidden forces that shape our reality. In the silence of the night, as the stars twinkle in the velvet sky, we are reminded of our place in the cosmos, a single thread in the grand tapestry of existence.
As we gaze up into the night sky, a vast canopy of stars greets us, each point of light a distant sun, perhaps with its own retinue of planets. Yet, beyond this glittering expanse, a profound truth lurks, one that has reshaped our understanding of the cosmos. The universe is expanding. This notion is not merely a metaphorical expansion of our minds, but a literal swelling of space itself, a revelation that transformed astronomy in the 20th century and continues to enthrall those who ponder the nature of existence. It was Edwin Hubble in the 1920s who first provided evidence for this cosmic expansion. Observing the light from distant galaxies, Hubble noted a curious shift towards the red end of the spectrum, a phenomenon now known as redshift. This shift suggested that these galaxies were moving away from us, and not just a few, but nearly all of them. The universe, it seemed, was not a static entity, but a dynamic, ever-growing tapestry. In the vastness of the cosmos, this expansion is a gentle drift.
imperceptible to our everyday senses. Yet on the grandest scales, it becomes the dominant force, stretching the fabric of space-time itself. Imagine, if you will, an enormous loaf of raisin bread baking in the oven. As the dough rises, each raisin moves away from the others, not because they are actively traveling, but because the dough itself is expanding. Our universe behaves in a similar manner, with galaxies as raisins carried along by the cosmic loaf. But what fuels this expansion? The answer lies in a mysterious phenomenon known as dark energy. This enigmatic force constitutes roughly 68% of the universe, yet its nature remains elusive. Unlike gravity, which pulls objects together, dark energy seems to push them apart, accelerating the expansion of the universe. It is as if the universe possesses a hidden breath, gently exhaling and causing the cosmos to swell ever outward. The discovery of dark energy was as unexpected as it was profound. In the late 1990s, two independent teams of astronomers studying distant supernovae found that these exploding stars were dimmer than anticipated. This implied that the universe's expansion was not slowing, as many had assumed, but accelerating. Dark energy, it seemed, was driving this expansion, a force so pervasive and yet so subtle that it had gone unnoticed for much of human history. As we ponder the implications of dark energy, we are drawn into a contemplation of the future. If this expansion continues unchecked, what will become of the universe in the distant eons to come? One possibility is the so-called Big Freeze, a scenario in which galaxies drift so far apart that their light becomes too faint to see. Stars will exhaust their nuclear fuel, and the universe will gradually darken, a cold, sparse expanse where only the faintest whispers of creation remain. Yet, in the quiet contemplation of such a distant future, there is also a sense of wonder. The expansion of the universe, with its vast, unending possibilities, invites us to explore not only the physical cosmos, but the very nature of reality itself. It challenges us to consider our place within this grand design, to reflect on the fleeting beauty of the stars and the enduring mystery of the dark. In this ever-expanding universe, where galaxies dance in the vast ballroom of space-time, we find a reminder of our own insignificance and our potential for discovery. The universe, in its boundless complexity, beckons us to look beyond the horizon, to seek out the unknown, and to embrace the journey of exploration. For in the end, it is not the destination, but the journey itself that defines us, a cosmic voyage that continues to unfold with each passing moment. As we drift into slumber, let us carry with us the gentle hum of the universe's expansion, a lullaby of distant worlds and cosmic wonders. In the quietude of the night, the stars whisper their ancient secrets, and we, the dreamers of Earth, listen with hearts open to the infinite possibilities of the cosmos.
In the vast tapestry of the cosmos, there exists an artist whose brushstrokes are both invisible and profound. This artist is gravity, a force so fundamental yet elusive that it shapes the very fabric of our universe in ways both grand and subtle. As we drift through the corridors of space and time, gravity gently guides our journey, its influence woven into the narrative of every star, planet, and galaxy. Gravity, in its essence, is the silent architect of the universe,
It is the force that draws together the scattered particles of cosmic dust, which, over the eons, coalesce to form stars. These stars, in turn, are the building blocks of galaxies, vast cities of light that illuminate the dark canvas of the universe. Without gravity, these celestial structures would scatter into the void, formless and unbound, like a symphony without a conductor. Consider, for a moment, the elegance with which gravity orchestrates the dance of the planets. Our own solar system is a testament to this cosmic choreography. Each planet follows a path, an orbit forged by the gravitational pull of the Sun. It's a dance that has persisted for billions of years, a delicate balance between the inward pull of gravity and the outward push of inertia. The Earth, our blue oasis in the vastness of space, maintains its gentle orbit at just the right distance from the Sun, a serendipitous alignment that allows life to flourish. The influence of gravity extends far beyond the familiar confines of our solar system. It sculpts the grand spiral arms of galaxies, those swirling starry whirlpools that captivate our imagination. The Milky Way, our galactic home, owes its majestic spiral form to the gravitational interactions between its stars and the mysterious dark matter that pervades the universe. This invisible substance, detectable only through its gravitational effects, adds weight to galaxies, holding them together and shaping their evolution. Gravity's role as the universe's architect also reveals itself in the cosmic phenomenon of black holes, those enigmatic regions where gravity's pull is so intense that not even light can escape. Black holes are born from the remnants of massive stars that have exhausted their nuclear fuel and collapsed under their own gravity. In these cosmic abysses, gravity reigns supreme, warping space and time in ways that challenge our understanding. Yet, gravity, for all its might, is a force that we still strive to comprehend fully. It is one of the four fundamental forces of nature, alongside electromagnetism, the strong nuclear force, and the weak nuclear force. But unlike its counterparts, gravity is unique in its ability to influence on such vast scales. Its reach is infinite, its pull unyielding, yet it is the weakest of the fundamental forces when measured on the scale of atoms and molecules. This paradox is one of the many mysteries that continue to intrigue scientists. Einstein's theory of general relativity provides us with a profound insight into the nature of gravity. According to this theory, gravity is not merely a force in the traditional sense, but a curvature of space-time itself. Massive objects like stars and planets bend the fabric of space-time, and it is this curvature that guides the motion of objects, much like a marble rolling along a warped surface. This elegant idea has withstood the test of time, its predictions confirmed by numerous experiments and observations. One such confirmation came from observing the deflection of starlight by the Sun's gravity during a solar eclipse, a phenomenon predicted by Einstein and observed by Sir Arthur Eddington in 1919. This bending of light, known as gravitational lensing, is now a key tool for astronomers, allowing them to study the distribution of dark matter and the large-scale structure of the universe. As we reflect on the role of gravity as the universe's architect, we are reminded of its dual nature, a force that both binds and inspires. It holds the cosmos together, yet it also propels us to explore, to seek out the secrets of distant worlds, and to understand our place within this grand cosmic tapestry. Gravity is the gentle hand that guides us, the silent force that shapes our destiny among the stars. In the quiet moments, as we lie beneath the night sky, we can sense gravity's embrace, a reassurance that we are part of something much larger than ourselves. It is a reminder of the interconnectedness of all things, a cosmic harmony that resonates through the universe, inviting us to wonder and wonder, to dream and discover. In understanding gravity, we come closer to understanding the universe itself, and in doing so, we find a reflection of the infinite possibilities that lie within our own wandering minds.
In the quiet vastness of the universe, there exists a delicate dance between time and space, one so intricate that it forms the very fabric of the cosmos itself. This is not merely a poetic notion, but a scientific reality, a concept that has intrigued and puzzled humankind for centuries. As we delve into this profound topic, let us imagine the universe as a grand tapestry, with time and space as the threads woven together to create the cosmic masterpiece we observe. The notion that time and space are interwoven was not always accepted. For much of human history, these concepts were seen as distinct and separate. Space was the vast expanse in which the stars twinkled, and time was the relentless march of seconds, minutes, and hours. It was not until the early 20th century, with the pioneering work of Albert Einstein, that our understanding of these concepts underwent a revolutionary transformation. Einstein's theory of general relativity proposed that space and time are not independent entities, but rather are interconnected, forming a single four-dimensional continuum known as space-time. Imagine for a moment a vast invisible fabric stretched across the universe. This fabric is space-time, and it is upon this stage that the drama of the cosmos unfolds. Planets, stars, and galaxies move through this fabric, and their presence causes it to curve and warp. It is this curvature that we perceive as gravity. To visualize this, consider a heavy ball placed on a trampoline. The weight of the ball causes the trampoline to sag, creating a dip around it. Now, if we roll a smaller ball across the trampoline, it will naturally follow the curve created by the heavy ball, illustrating how space is warped by the presence of mass. This analogy, while not perfect, offers a glimpse into the elegant simplicity of Einstein's insight. Time, too, is affected by this warping of space-time. In regions of intense gravity, such as near a massive star or a black hole, time itself slows down. This phenomenon, known as time dilation, means that clocks in these high-gravity areas tick more slowly compared to those in regions of weaker gravity. If we were to observe a clock near a black hole, it would appear to tick at a sluggish pace relative to one on Earth. This might seem counterintuitive, yet it has been confirmed by precise measurements and experiments, such as those involving atomic clocks flown in aircraft. The implications of time dilation are profound and stretch the boundaries of our everyday experiences. It suggests that time is not an absolute constant, but a malleable dimension that can stretch and contract depending on the gravitational forces at play. This realization challenges our intuitive understanding of time as a linear, unchanging flow. Our perception of time and space is further complicated by the vastness of the universe. When we gaze up at the night sky, we are not merely looking at distant stars, we are peering back in time. The light from these celestial bodies has traveled across the universe, sometimes for millions or even billions of years, before reaching our eyes. In this way, the sky becomes a time machine, offering glimpses into the ancient past of the cosmos. The interplay between time and space also gives rise to some of the universe's most enigmatic phenomena, black holes. These are regions where the warping of space-time becomes so extreme that nothing, not even light, can escape their grasp.
At the heart of a black hole lies a point of infinite density known as a singularity, where the known laws of physics break down. Here, space and time intertwine in unfathomable ways, and our understanding of them is pushed to its limits. In contemplating the fabric of the universe, we find ourselves marveling at the delicate balance and interconnectedness of all things. Time and space, once thought to be simple backdrops to the cosmic play, reveal themselves as dynamic participants in the unfolding narrative of the universe. They shape the very essence of reality, influencing everything from the motion of galaxies to the passage of time itself. As we draw our exploration of time and space to a close, let us pause to appreciate the wonder of it all. The universe, in its vast complexity, reminds us of the beauty inherent in the mysteries we have yet to unravel. Though the true nature of time and space may elude our full understanding, their dance continues to inspire and challenge us, inviting us to look deeper into the cosmos and into our own minds. And so, as we drift into sleep, let us carry with us a sense of awe for the universe's grand tapestry, woven from the threads of time and space. In this quiet reflection, we find a gentle reminder that we are all part of the cosmic story, our lives interwoven with the vast, mysterious fabric that stretches across the stars.
In the vastness of the cosmos, where the silence is as profound as the darkness is deep, there exists a beauty that is both ancient and ever new. This beauty is not simply in the twinkling of distant stars or the swirling patterns of far-off galaxies. It is in the quiet harmony of the universe itself, a delicate balance of forces and phenomena that has inspired human curiosity since we first gazed up at the night sky. Imagine, if you will, standing on a quiet hilltop on a clear night, far from the intrusive lights of human habitation. Above, the sky stretches out like an endless canvas, each star a tiny distant sun, each constellation a story passed down through generations. In these quiet moments, we are reminded of our connection to the universe, a reminder that we are but a small part of something much larger than ourselves. The cosmos is a tapestry woven with the threads of time and space, a dynamic interplay of matter and energy. Its beauty lies not only in its vastness, but in the intricate details that make up the whole. Consider the delicate dance of the planets, each orbiting its star in a cosmic ballet choreographed by gravity, or the majestic spiral arms of a galaxy, each one a swirling collection of stars, dust, and gas moving together in a graceful spiral dance. Within each galaxy, there are billions of stars, and around many of these stars are planets of all shapes and sizes. Some are rocky and barren, others are gas giants with swirling storms of unimaginable power. And yet, amidst this diversity, there is a unifying thread, the laws of physics that govern all celestial bodies, from the smallest pebble to the largest star. These laws are the language of the universe, a language that we have only just begun to decipher. Through the patient work of astronomers and physicists, we have learned to read the stars, to understand the forces that shape galaxies, and to explore the mysteries of black holes and dark matter. Each discovery adds a new layer to our understanding, revealing a universe that is both stranger and more beautiful than we ever imagined. But beyond the scientific, there is a more philosophical beauty to the cosmos. It calls to the human spirit,
inviting us to ponder our place in the vast expanse of space and time. As we reflect upon the cosmos, we find ourselves drawn into a deeper contemplation of existence itself. What is our role in this grand design? How do we fit into the cosmic puzzle? The beauty of the cosmos lies also in its ability to inspire. It has been a muse for artists and poets, a challenge for scientists and philosophers. It invites us to dream, to imagine what might be possible, and to reach beyond our earthly bounds. In the quiet moments of reflection, we find ourselves touched by the sublime, a feeling that transcends words and resonates deep within our being. As we gaze upon the night sky, we are reminded of the transient nature of our own existence. Stars are born, live their lives, and eventually die, their remnants seeding the cosmos with the building blocks of new stars, new planets, and perhaps new life. This cosmic cycle of birth and rebirth mirrors the cycles of life on Earth, connecting us to the universe in a profound and intimate way. The beauty of the cosmos is not static. It is ever-changing, ever-evolving. New stars are forming as others die. Galaxies collide and merge, and the universe itself continues to expand. In its constant state of flux, the cosmos teaches us about the nature of change and the inevitability of transformation. Reflecting on the cosmos invites us to consider the unity and diversity of existence. Just as the universe is composed of countless stars and galaxies, so too is our world a tapestry of cultures, languages, and ideas. Each contributes to the richness of the whole, a reminder that diversity is a strength to be celebrated. In this reflective pause, we are reminded that the beauty of the cosmos is not just out there in the distant reaches of space. It is here, within us, in the wonder and curiosity that drive us to explore the unknown. It is in the questions we ask, the dreams we chase, and the connections we forge with one another. As we conclude this moment of reflection, let us carry with us the awe and inspiration that the cosmos bestows. Let us continue to explore, to question, and to marvel at the beauty that surrounds us, both in the skies above and in the world around us. For in these moments of quiet contemplation, we find not only a deeper understanding of the universe, but also a greater appreciation for our own place within it. As we drift into the gentle embrace of our final thoughts, it is fitting to consider the endless journey upon which we find ourselves. The cosmos, in its infinite expanse, holds mysteries that beckon us with a quiet allure. It is a landscape vast beyond measure, where every star is a beacon of curiosity, each planet a potential harbor of secrets waiting to be unveiled. Our voyage through the universe is not merely one of scientific inquiry, but a deeply human endeavor, woven into the very fabric of our existence. The night sky, with its tapestry of stars, is a reminder of our place in the universe. We are, in many ways, stardust given life, consciousness born from the remnants of ancient supernovae. This cosmic connection instills in us a profound sense of wonder. The atoms that comprise our being were forged in the hearts of stars, and in contemplating the heavens we engage in a quiet dialogue with our origins. Space exploration is more than the pursuit of new worlds. It is the pursuit of understanding.
The universe invites us to look beyond the confines of our daily lives, to imagine possibilities far removed from our immediate experience. It is a journey that stretches the limits of our imagination and challenges us to rethink our place in the vastness that surrounds us. Consider for a moment the Voyager probes, those intrepid emissaries of humanity launched eons ago, now drifting silently through the cosmic ocean. Each carries with it a golden record, a time capsule of Earth, a message in a bottle cast into the interstellar sea. These spacecraft, small by the standards of celestial bodies, are our ambassadors to the stars, carrying whispers of our civilization into the unknown. They remind us that even the smallest of ventures can have profound implications, that our reach exceeds our grasp, yet we strive forward nonetheless. The pursuit of knowledge is an unending odyssey. With every discovery, new questions arise, each more tantalizing than the last. The more we learn, the more we realize how much there is yet to understand. This is the beauty of science. It is a journey without a destination, an endless quest for insight and comprehension. It is this very boundlessness that keeps our minds engaged, our hearts open to the wonders that lie beyond. In contemplating the cosmos, we find ourselves humbled and inspired in equal measure. The scale of the universe dwarfs our individual existence, yet it also elevates it. We are tiny in the grand scheme of things, yet significant in our capacity to dream, to explore, and to marvel at the universe's grandeur. It is this duality that defines our relationship with the cosmos, a dance of insignificance and importance, of curiosity and awe. As we gaze into the night sky, we are reminded of the countless generations who have done the same, each looking up in wonder, asking the same questions, and feeling the same yearning for understanding. We are part of a continuum, a long line of seekers who have gazed at the stars and pondered the infinite. This shared exploration binds us across time and space, a testament to our enduring spirit of inquiry. Our journey through the cosmos is not solely a scientific endeavor, it is a philosophical one as well. It prompts us to reflect on the nature of existence, the passage of time, and the interconnectedness of all things. The universe, in its vastness, offers a perspective that is at once humbling and enlightening. It asks us to consider not just where we are, but who we are, and what we aspire to become. In the stillness of the night, as we lie beneath the stars, we are reminded of the quiet majesty of the universe. It is a reminder that despite the noise and chaos of everyday life, there is a calmness to be found in the contemplation of the cosmos. The stars, in their silent splendor, offer a moment of reflection, a chance to pause and breathe, to find peace in the knowledge that we are part of something much greater than ourselves. Thus the journey of exploration and wonder continues, an endless path through the mysteries of the universe. It is a path that invites us to keep asking questions, to remain curious, and to never cease in our search for understanding. As we close this chapter, let us carry with us the spirit of discovery, the joy of curiosity, and the peace of knowing that the universe, in all its vastness, holds a place for us within it. May we continue to look to the stars with wonder in our hearts, ever eager to explore the boundless possibilities that lie beyond. For the journey of the mind is as infinite as the universe itself, and it is only just beginning. As we drift into slumber, let us dream of distant worlds and cosmic mysteries, knowing that the journey is endless and the wonders are without limit.